Hello, this is a video on section 7.2, graphs of polar equations. This video is going to be slightly different than some of the other videos because we're not going to go into much depth involving graphs of polar equations. Although the graphs are super cool and interesting to look at, we really don't get into them very deep. But if you find that it's something that interests you, I encourage you to take the time to look at it. So all of these objectives here we will not really cover, but the thing that we need to understand is that sometimes polar equations don't result in a rectangular equation that we recognize. So these graphs that you're going to see are something that are new, likely. So graphing polar equation by plotting points, basically what you can do is just plot a whole bunch of different ordered pairs and graph it and see what happens. One thing you will find are circles, and circles are not something new. It's something we've seen before, but these circles are going to take on different equations. And those equations are going to look something like these. So basically, this first one, you have r is equal to 4 sine of theta. The blue one is negative 4. So you can see that if sine is involved, depending on what this value is, it will be above or below the x-axis. On the other hand, if cosine is involved, the negative value will be to the left of the y-axis, and this will be to the right. So these equations are different than what we have seen the equation of a circle looking like. You will see something called a limacon. Basically, these here are a little bit different, and I'll show you what that looks like here in a second. But these equations take on one of these two forms. So I want you to notice how the equations differ from each type of graph. And so depending on what this graph looks like, the orientation will change. So we might have right, up, down, and left. And here's what a limacon looks like. It will look like this, where it will have this little loop in the middle, or it will have a dimple, which is just adorable. Just a little bit of an indentation there. A limacon can also be categorized as a cardioid, which is a heart shape. And then finally, it could also be convex, so it will look something like this. Here are a few examples of what these limacons could look like. Since sine is involved, that means that we will either be up or down. In this case, since this is negative, it will be shifted downward. Same thing here and here. Okay, so these are just 3 different types of limacons that you could see. You may also see something that looks like this. In this case, we are dealing with cosine instead of sine in the previous slide. So we know that it's going to kind of shape itself right or left. And in this case, because this is negative, it's going to be a cardioid left. Okay. In this section, you will also see information regarding roses. These take on this or this parent function, if you will. And depending on how that function is altered, it will change the way the rose looks. So here it gives you some different information regarding the graphs. And you know, with technology today, we're not going to take the time to graph these by hand, and that's why I'm going so quickly through this video. So if you are interested in graphing these by hand, you're welcome to read through the text and it will give you some information. But the things I want you to know about roses are the number of petals. If n is odd, so this value here, if this is odd, there will be n petals. However, if that is even, there will be 2n petals. This other information here is important if you were to graph this by hand. Okay, so here's one example. This 5 tells us the petal length. And this is n. Since it is even, we know that we will have 4 petals, as you can see here. And if you want to find out the location of the petals, that information's on the previous slide. So here is another example. The petal length in this case is the absolute value of this value here. So the petal length is 6. Since n is odd, there will be 3 petals, as you can see in the graph below. And these are examples of roses. Here is another example, and one nice thing, you can graph these in Desmos. So if you go to desmos.com, you can graph this as you see it. You can type in r equals 4 sine of 3 theta. If you type in theta like this, it will turn it into the symbol, and boom, this beautiful graph of a rose will pop out. Another type of polar graph that you will see in this section are lemniscates, which take on this form here. These will have lobes of different length, and you can examine that here. Here are some examples of what you will see. Basically, this will have, we take the square root of this value, to find the lobe length. So the lobe length here is 5, and here it is 8. Spirals. There are Archimedean spirals and logarithmic spirals, so they just take on different forms, and they will look a little bit different, like this and this. So very similar, but slightly different. Lines should not be anything new. So if you have theta equals 0, this is the x-axis. Theta equals pi over 2 is the y-axis. If we have some other value for theta, it's a line through the origin. It just depends on what theta is equal to. So if we represent a line using this equation, that is a horizontal line. Because if you multiply both sides by sine of theta, like in the previous section, you will have r sine of theta is equal to a, and remember r sine of theta is equivalent to y. So if you have y equals some number, that is a horizontal line. Same type of thing here, this will just represent a vertical line. This is likely the shortest video you will have in this class. I hope you enjoyed it.